Good morning, students, and welcome to Introduction to Database. This is Chapter 1, Overview of Databases. The objectives. After studying this chapter, you should be able to define each of the following key database-related terms, such as data, information, data processing, database, and a database management system, or DBMS. Second, discuss conventional file processing system and its limitations. Then, discuss the concepts of database and DBMS. Fourth, discuss future trends and technologies in relation to databases. And lastly, explain the different types of database users. So, let's begin. And I will begin by asking you a question. Have you ever tried opening the CIMS or the College Information Management System lately? And have you successfully logged in and viewed your timetable this semester? If so, then, have you ever wondered where those login details and all the other data are stored? The answer is in a database. When you open CIMS and check the courses you have enrolled this semester, or check your details, all of these data about you are stored in a database on a physical computer in the university. So technically, a database is a centralized and structured set of data stored in a computer system. It is where data such as numbers, texts, files, pictures, videos, and audios are stored or kept. A database provides facilities for transforming retrieved data into useful information. Nowadays, data is more important and most of the work are based on the accuracy of data, so more and more data is collected for different purposes, like scientific research, academic, commercial use, and institutional use. And once we have the data collected and stored in the database, we must process the data collected so that it can be stored and presented in the required usage format. The technical term is data processing. Data processing is the conversion of data into a usable and desired form. From numbers, text, pictures, converted into a useful information needed by organizations that collect these data. Now, a database is also defined as the shared collection of logically related data. For example, universities collect data about students, lecturers, courses, advisors, departments, and others. But if you take a closer look, these collected data are all related or connected. Students take courses, and these courses are taught by lecturers. Students have advisors to assist their academic journey. Lecturers are assigned in departments such as IT, engineering, or business. Now, these data are not randomly stored. They are collected for a reason, and they are all logically related or connected. Databases also store descriptions of these data, and all these are designed to meet the information needs of an organization. So here is the basic components of a database system, just to give you an idea as to how databases process data into information. Now, an organization, such as a university, collects data from its students, staffs, and administrators. Or, if it's a grocery store, then data are gathered from its customers and suppliers. The data collected through the application programs are stored in a database. These data in a database is then processed by using a query that will search, organize, or sort only the specific data needed, or by using software tools to process the vast amounts of data in order to produce information that is in a usable format that will be the basis for making a decision in the organization or to generate reports that will benefit the organization. Now, let's take a closer look at the terms data and information. Data are collected facts about a topic or item. These facts can be in a form of numbers, text, characters, files, pictures, videos, and audios. For example, a name of a student, it's a text. Age of a student, it's a number. F here, in this example here, F is a character which refers to the gender of the student. Diploma is a text. It is about the year level of this student. And all of these collected data are about students. What do we do with this data? These data are then stored in a database that will then be ready for processing. Now, once you have a processed data, you then get information. The result of processing, combining, comparing, and performing calculations on this raw data is called information. Therefore, when data are processed, interpreted, organized, structured, or presented so as to make them meaningful or useful, they are called information. If you have here a data about students stored in a database, and we use processing tools such as querying and other tools, we can then produce an information. Say, based on the data from CIMS, the number of enrolled students for the first semester of academic year 2020 and 2021 has decreased by 10%. And this information can then be used by the organizations such as the university to make decisions or reports for their organization. And here are some other examples of data and information. Data into the database, for example, the yearly income, they are stored in a database, and then based on that data, we can then produce information out, such as next year's budget based on previous income. Or we have here 312 graduates are stored in a database. Then we can then produce an information out or make a decision based on that data. So here are other examples of data and information. Each student's test score is one piece of data. So here are some test scores of students. If we process these test scores, such as maybe the class's average score or the school's average score, we can then get an information. For example, in the first semester of academic year 2019-2020, the class average for ITDB 101 is 80.5. That is information, and that can be used to make decisions for the next semester. And here are other examples of data and information. Now, before databases were invented or created, data is managed using a file-based system. So we will briefly discuss the traditional file system concepts. A file management system is also known as a file system or a file-based system. It is the most ancient and one of the most popular way to keep your data files organized on your drives. A file system is a software that manages the data files in a computer system. File system helps to store a collection of raw data files into the hard disk, such as storing, retrieving, and searching are done manually in a file system, and it is installed into the computer with the operating system. In this traditional file system, each file is independent of other files, and data in a different file can be integrated only by writing an individual program for each application. The data and application program that uses the data are arranged so that any change to data requires modification of all programs that use the data. All functional areas in the organization create and process its own files through a collection of application programs that perform services for the end users. And each program defines and manages its own data. So here is an example of a banking system using file-based system. This bank has 3 departments: personal, account, and loan departments. Each department uses different application programs. Let's say personal has application program 1, account has application 2, and loan has Software Application 3. In the traditional way of managing data, an application program connects to the file system, and the file system accesses the files for that application program. So in this example, the personnel department uses the employee file. Account accesses two files, checking and savings, while the loan department uses the mortgage and installment files. It seems fine at first glance, but file-based systems have several disadvantages or problems in managing data. That is why databases were invented to address these problems. Now let's discuss briefly the disadvantages of file systems. First is data redundancy. Each application has its own data files. Some information may be kept in different files or places. Redundancy may lead to inconsistency, which means copies of the same data are conflicting. Second is program data dependency. File descriptions or structures are stored within each application program that accesses a given file. Any change to a data file description or structure requires changes to the file descriptions for all application programs that access the file. The third is data integrity problems. Data values present in the data file may require satisfying certain constraints or restrictions. These constraints must be applied through each application programs accessing data from that data file. Any change in the constraint or enforcing a new constraint must be changed or added in all the application programs accessing the file. Therefore, it is difficult to add change to the programs to enforce new constraint. And lastly, concurrent access anomalies. Concurrent access is the ability to allow multiple user access to the same record at the same time. A file-based system must manage or prevent concurrency by the application programs. Typically, in a file-based system, when an application opens a file, that file is locked. This means that no one else has access to the file at the same time. Here is an example of a file-based system in college and the disadvantages found in this system. The first one is data redundancy. Data redundancy refers to the duplication of data. For example, students' information is maintained in the Students' Affairs Department and in the Academic Department. The same student's details in such case will be stored twice. Therefore, this duplication is wasteful because it requires additional storage space. Data redundancy also leads to data inconsistency. If any student made a request to change his address, if the address is changed at one place, say in the Students' Affairs Department, and not changed in another place, such as in the Academic Department, the student's address is not same at all the places. The next one is program data dependency. Change in the data file structure would lead to change in application programs that access a given file. For example, in the college system here in the picture, Program A accesses the lecturer file in HR department. Because Program A contains a detailed lecturer file description, any change to a lecturer file structure requires changes to the file description in Program A. Suppose it is decided to change the lecturer address field length in this file from 25 to 30 characters. The file description in Program A would have to be modified. Therefore, there is program data dependency. And the last problem is data integrity problems. Change in the constraint or limitations in data item in a data file need to change all the application programs accessing the data file. For example, in this college system, Program B and C accesses the student file in the Students' Affairs Department, and there is change in the constraint on the phone field now. And now the phone number can start with 9 or 7 digits. Now the constraint must be changed in all the programs accessing the student file in the Students Affairs Department, such as in this case, program B and C will have to be changed. Therefore, it introduces integrity problems. This is the reason why databases are created, and it is to address the problems that were encountered in using file systems. Now, let's move on from the old into the new. We now know that a file-based system is an ancient, if not an old way of managing data collected by organizations, and database and DBMS is now the standard. But databases have also improved to cater to the current data demands in this digital age. So, let's briefly touch the surface of the current technologies and trends in this digital age. And we begin with Industry 4.0. Industry 4.0 refers to a new phase in the Industrial Revolution that focuses heavily on interconnectivity, automation, machine learning, and real-time data. It is also sometimes referred to as IIoT, or smart manufacturing, connecting physical production and operations with smart digital technology, machine learning, and big data to create a more holistic and better connected ecosystem for companies that focus on manufacturing and supply chain management. IR 4.0 takes the emphasis on digital technology from recent decades to a whole new level with the help of interconnectivity through the Internet of Things, or IoT, access to real-time data, and the introduction of cyber-physical systems. Here are some terms related to Industry 4.0. The first one is IoT. It stands for Internet of Things. It is a concept that refers to connections between physical objects like sensors or machines and the Internet. Then you have the IIoT. It stands for the Industrial Internet of Things. It's a concept that refers to the connections between people, data, and machines as they relate to manufacturing. Then we have big data. It refers to large sets of structured or unstructured data that can be compiled, stored, organized, and analyzed to reveal patterns, trends, associations, and opportunities. So databases are involved in big data. Artificial intelligence, or AI, is a concept that refers to a computer's ability to perform tasks and make decisions that would historically require some level of human intelligence. While cloud computing refers to the practice of using interconnected remote servers hosted on the internet to store, manage, and process information. With Industry 4.0 and the current trends in technology, managing vast amounts of data collected from these information systems and other interconnected systems require a powerful approach, and that is through the use of databases. So database and database technology play an important role in most of social areas where computers are used, including in business, education, medicine, and etc. To understand the fundamental of database system, we start from introducing the basic concepts in this area. So in the first part of this chapter, you already have an idea as to what databases are. So, again, a database is a shared collection of related data used to support the activities of a particular organization. Database can be viewed as a repository of data that is defined once and then accessed by various users of the system. Now, do organizations need a database as a solution to managing their data? The answer lies in the organization's data, users, and their needs. So, if an organization has multiple users, such as a university with many students accessing their academic data, and there are multiple data items, for example, data items about students, lecturers, departments, and etc., and there is a need to integrate or connect multiple components or connect data items, so then a database solution is needed. There are so many use cases or examples where a situation requires the use of the database approach, and these are some of them. Schools and colleges use databases to maintain details about courses, students, and faculty. Banks use databases for storing information on customers, accounts, loans, and transactions. Airlines and railways use online databases for reservations and for displaying information on the schedule, while telecommunication departments store information about the communication network, telephone numbers, call details, and monthly bills in databases. Organizations use databases for storing information about employees, salaries, benefits, taxes, and for generating paychecks. And there are so many use cases where database approach is the solution. We now know that a database can be viewed as a repository of data. But how will these stored data be managed? The answer is a DBMS. DBMS, or a Database Management System, is a collection of programs that enable users to create, maintain the database, and control all the access to the database. It provides an environment that is both convenient and efficient for users to retrieve and store information. Users will use the SQL, or Structured Query Language, to communicate with a database management system. This is the query that I mean in the basic components of a database system. Now, to give you a wider view, here is an illustration. Inside a database system lies the DBMS. The DBMS has a direct access to the database and manages its relationships. Inside the database are collections of data about several items. For example, data items about students, lecturers, departments, courses, and so on. And all the logically related data are stored in a database. Now, application programs such as a mobile application or a website or a desktop application, which is part of the database system, can access data in a database but through the DBMS. And users using these application programs can access their data through the DBMS. Examples of DBMSs are Oracle Server, MS SQL Server, MySQL Server, and many more. Now let's take a look at this example, which shows the same banking system but is now implemented using the database approach. As you can see in the illustration, the application programs of the three departments, personnel, account, and loan, is now connected to the DBMS. If the personnel department wishes to access the employee's data item, their application program will connect to the DBMS first, and then the DBMS will then access the employee's data. Therefore, the DBMS is the link or bridge between the application programs of the different departments and the database, which is the storage of data. Also, note that the data items are stored in a single database, so these are shared by all departments. If before personnel are the only ones who can access employees, other departments with the right limitations can also access employees and the other shared data items. This leads us to the advantages of the database approach. With the database approach, there is reduced data redundancy. In this approach, ideally, each data item is stored in only one place in the database. For example, all the student details exist only in one place or in one file. However, in some cases, redundancy still exists to improve system performance, but such redundancy is controlled and kept to a minimum. The second advantage is program data independence. In the database approach, the data structure or metadata is stored in the system catalog and not in the application programs. Therefore, one change is all that is needed to change the structure of a file. It enforces integrity constraints. The DBMS must provide the ability to define and enforce certain constraints to ensure that users enter valid information and maintain data integrity. A database constraint is a restriction or a rule that dictates what can be entered or edited in a table, such as a postal code using certain format or adding a validity in the city field. Lastly, concurrent access. The DBMS includes concurrency control subsystem to ensure that several users trying to update the same data do so in a controlled manner so that the result of the updates is correct. And these are the reasons why today's information systems uses the database approach instead of the older file-based systems. Now we're down to the last part. Who uses the database? Well, all of us, mostly. If somehow you have used an information system such as e-learning, CIMS, or email, or social media, then you are a database user. But there are different types of database users. The first one are end users. That's you and me and mostly all of us. Well, all of us. End users are those who access the database from the terminal end, say a mobile application, a website, a PC. They use the developed applications and they don't have any knowledge about the design and working of databases. These are the class of users and their motto is just to get their task done. The next type of users are database designers. Database designers define the content, the structure, the constraints or limitations, and functions or transactions against the database. They must communicate with the end users and understand their needs. In this course, Introduction to Database, you will get to design or practice designing a database. Next type of users are application programmers. These users implement specific application programs to access the stored data. They must be familiar with the DBMSs to accomplish their task. These are the programmers. They need to have the knowledge to connect and program the applications that they are building to the database management system that is used. And the last one are the database administrators or DBA. DBA can be a single person or it can be a group of person. They are responsible for everything that is related to databases. A DBA is responsible for deciding the instances of the database, defining the schema, how it will be structured, what would be the items, how they are connected and related with each other, communicating with users, end users, defining the security of the database because we know that if we have data, we can get information out of it, so it needs to be secured. And lastly, backup and recovery. They are responsible for doing backup and recovery through the use of the database management systems. And those are the different types of users of a database. So in summary, we have discussed the concept of a database, difference between data and information, the older way of managing data, which is through file systems, the current technologies and trends, and we moved into the database approach, which is the solution to most of the problems encountered in the older way of managing systems. And lastly, we discussed the different types of database users. That ends Chapter 1. So this material is a derivative copy of Database Design Concepts by Nguyen Kim An, licensed under Creative Commons Attribution License 3.0 and the Oracle Academy Database Design material. Thank you, students, and see you in Chapter 2.